Fakhar. I'm a solutions engineer here with Hortonworks in the Bay Area. So today I'll take you through some of the new capabilities we've added in the platform from an ops perspective, an operations perspective, and I'll also be talking about what our vision is for doing HDP deployments on the cloud. So really, when we talk to enterprise customers about the cloud, one of the biggest themes that we hear from the enterprise customers is that when it comes to cloud and on-prem, they don't want it to be an either-or discussion, right? They want it to be a hybrid discussion, an and discussion. And it's not surprising that we get that feedback because if you think about it, if you're a Fortune 100, Fortune 250, Fortune 500 company, you've probably spent the past 10, 20 years investing heavily in systems, both infrastructure and software, that does run on premise, that has valuable data that needs to be analyzed, that continues to generate valuable data for analysis, right? And those customers don't want to throw away those investments in one big bang, right, and migrate everything into the cloud in one big go because it just doesn't make sense from an economic perspective or a risk perspective. However, having said that, most of the enterprise customers also have newer apps, newer workloads that are being developed that are very good fit for the cloud. So, it could be, for example, a mobile app server backend that's generating click streams from mobile apps running in the cloud somewhere, or tap streams if it's a native app, right? If you think about your CRM data, Salesforce data maybe, that's also sitting somewhere in the cloud. You may have Marketo data, right? If you're using Marketo for marketing automation, that's sitting in the cloud as well, right? So it's a mix. And the requirements, the technical requirements we hear are really three big requirements. One is the customers say that, hey, when I write a data-driven app today, a modern data-driven app, I should not really have to worry about whether it's going to work on-prem or in the cloud. It should work in either place without my having to really change it. De-risk that for me. Number two, when I deploy a data platform, deploy HDP essentially, on-prem or in the cloud, there should be consistency. They give me tooling, give me strategies by which I can ensure that I've got really the exact same bits, and a similar cluster, both on-prem and in the cloud, so that my ops teams, are de-risked, so that, if I transfer an app from the on-prem to cloud or vice versa, if I bring a piloted app from the cloud into on-prem for some reason, it will just work. Right, that's the second requirement. And then the third requirement, which is important in a hybrid strategy, is the notion of data movement, right? You may want to move data from on-prem into the cloud or vice versa. You may have data sitting at the edge of the network, and a lot of people, when I say edge, they're like, oh, we're not in the IoT business. And you don't have to be in the IoT business to really be, thinking about the edge, because if you think about it, even if you're using any cloud service such as Salesforce or any other cloud service out there, relative to your analytics cluster, it is on the edge of the network. And you want to maybe pull data out of your CRM service, right, to be able to join it with other kinds of data and do an analysis on it, right? Classical 360 use case. So relative to your analytics cluster, your Salesforce CRM data is really at the edge of the network. How do I move that data securely and in a network-aware way, a smart way, right? So as I go through the talk track today, I'll go into technical details of how we deliver on those requirements. But I wanted to kind of set the sort of expectation on what customers are asking for from a hybrid cloud perspective, and I'll go into the technical details behind it. Let me first cover some of the capabilities we've added to HDP, running HDP on-prem in the data center. And most of you are probably familiar with this architecture, right? Just a quick recap. We've got two products, Hortonworks Data Flow and Hortonworks Data Platform. Data Flow is about data in motion, being able to stream in data in real time, as you saw in the morning demo today. My colleague Dhruv is going to be doing a much deeper dive on HDF, so I'm not going to talk much about that right now. And then, of course, there's the HDP. Once the data is landed into HDFS or in an object store as well, such as Azure Blob Store or Amazon S3 or Google Cloud Storage. how do you go about analyzing it, right? So these are sort of the two architectural pieces of the platform. What kind of investments have we made in HDP 2.5? We continue to invest in all the key areas that the customers that's important to enterprise customers, right? We are invested in security, and I'll cover some of those investments. We are continue to make investments in Spark. My colleagues Eddie and Binu are going to be doing an awesome session on Spark a little bit later today, and you'll get to see some of that. We continue to invest in HBase and Phoenix. We've made backups really easy with HBase and Phoenix and HTTP 2.5. Even if you want to back up HBase Phoenix data into the cloud, you can do so very easily now. We released an ODBC connector for Phoenix, which allows you to unleash all of that data to your analysts in the enterprise. And I'll start covering some of the cool things we've done in Ambari from an operations perspective, and Hive as well. So let's get into it. So let's talk about security first, right? What are we doing in the security space? So Hortonworks is the only vendor who really believes that security and governance are not two mutually exclusive concepts, right? These two need to work hand in hand. What do we mean by that, right? So you might be familiar with some of the governance and security pieces in the platform. Atlas is the component in the platform that deals with governance, and Ranger is essentially the enforcer of access control lists inside your Hadoop cluster. It does authorization. Atlas and Ranger work together. One of the ways that they work together is, if you think about governance, one of the key things that customers ask for when they talk about data governance is, I should be able to associate metadata with my physical data in the cluster, right? What does that mean? So let's say you've got a Hive table in your cluster, and you know that there's PII, or personally identifiable information, inside that Hive table. Wouldn't it be nice if you could tag that table as containing PII information, associate metadata, a metadata tag with that particular piece of data, right? So that you know that, okay, this piece of data has got PII information. If I transform it, if I move it, the tag moves along with it, and and I'll be able to track the fact that this piece of data is PII sensitive, right? That's what Atlas enables you to do. That's one of the things that Atlas enables you to do. Now, if you take that to the next level, you're like, well, okay, I know it's got PII information in it, and now I want to create a policy to restrict people from being able to access that PII information, right? That's where Ranger comes in. Ranger is capable of actually creating an access control list policy on metadata in the cluster. So you can create a policy in Ranger saying that all of the PII tag data in the cluster can only be accessed by one super user, or whatever policy you choose, right? That's extremely powerful. That is very powerful, because the traditional way of doing ACLs, right, in the data space is that, oh, I've got a table, I've got a column, I'm going to create a policy per table, per column, and for the 1,000 tables I have, it's going to be a policy per table, per column, and things like that. But being able to tag data and create policies on tags is a really revolutionary way of securing data in your cluster. And that's one of the capabilities that we've added, and G8 and HTTP 2.5. So what I just described to you is the basic tag policy. We've also added policies for things like geographic security. For example, in Europe, a lot of our customers say that, hey, the data cannot travel outside of European boundaries. It's against the law. So can you help us enforce that? So for example, you imagine an employee from Europe is, let's say, on a business trip in the US and happens to fire up Tableau and connects to your Hive cluster because they're on the VPN and they're trying to do queries, right? And they don't realize that they're breaking the law. Well, we can prevent that from happening, right? Because we can actually create geo-based policies saying that this piece of data actually cannot move a certain boundary. And we've got other advanced policies as well, things like time-based policies, where if you want to cut off access from 9 to 5, let's say for SOX compliance, we can do that. If you've got two different tables that you have access to, and you're not supposed to be able to join them, because if you join two tables sometimes, you can piece together a story that you're not supposed to be piecing together. That's called a prohibition policy. We can even handle that use case. So really the best-in-class security story in the Hadoop ecosystem, that's what we're offering. Some of the other things that we've added to Atlas are something called cross-component lineage. So if you imagine in your Hadoop cluster, you're probably ingesting data from multiple places, right? You may be scooping it in from a data warehouse or a relational database. You may be streaming it in from Kafka, Kafka or Storm path, right? And you may just be doing transformations from one Hive table into another, right? Transforming the table, putting it through an ETL process. You want to be able to track the lineage across all of those connectors, right? So we've added that capability. We call it cross-component lineage. So let's say the data gets scooped in from a relational source, or it comes in from Kafka Storm path, and then you run a Hive ETL transformation on it. You create 3 other tables out of it. You have to create maybe monthly or weekly views out of it. You can actually track that entire lineage now in Atlas from the beginning. The other thing we've introduced is the notion of a business catalog in Atlas, and this is really a very user-friendly, intuitive UI to be able to create the kind of metadata policies that I was talking about. So let's say you've tagged some data in the cluster, or you want to tag some data in the cluster as a business analyst or as a data steward. You can do so very easily from the UI here, the business catalog UI. And we also give you a search bar, a free-form text search bar. So let's say that you want to find out all of the PII tables, right, in your data lake. You can just go in there in the search bar, search for PII. It will bring you it'll return all of the PII information, right, in the cluster. These are tables with PII data. And then we also give you lineage views in the business catalog, so you can track the lineage that I was talking about, right, in a graphical manner. So those were some of the security and governance things we have delivered in 2.5. Let's talk a little bit about what we're doing on the operations side of things. So on the operations side of things, there's really a 3-phase approach that we've taken. The very first thing we delivered was something called Grafana in Ambari. And what Grafana is really a tool which allows you to chart and dashboard time series data very, very easily. And it really creates very beautiful, nice-looking charts on time series data. We've delivered that in Ambari so that you can track your health and performance metrics in a much nicer and more powerful way, and you can create your own custom dashboards on those metrics. So we integrated Grafana with the Ambari metrics system as a data source. And everything that Ambari metrics now outputs can now be charted with Grafana, and you can create some really cool visualizations. There's some pre-built dashboards that we ship with the product right now for HDFS, Yarn, and HBase, and we'll continue to ship more pre-built dashboards. But the whole idea is that you should be able to customize them as well. Take any metric coming out of Ambari metrics and customize it with a dashboard with Grafana. And this is one of the dashboards for HBase. You can see that we're essentially looking at the performance of the HBase block cache here, right? Cool stuff. Then there is the second investment we're making on the ops side is something that customers have been asking us about for quite some time, and it's really important functionality. This is being delivered with SmartSense 1.3.0. And the idea here is that customers have been saying that, hey, I want visibility into how my cluster is being used, right? Who are the most, who are the top 10 or 20 tenants in my cluster who eat up most of the resources? What are the top 10, 20, or top 30 jobs, resource-intensive jobs? What are the jobs that actually, or queries that are actually the most wasteful queries? Things like that. I want visibility into how my cluster is being used. And there are a couple of reasons why customers ask for that. One of the reasons is if you have a multi-tenant cluster and you've got multiple lines of business, multiple users in it, you want to sometimes be able to do a chargeback, right, internally. So you can charge the use of the cluster back internally to business units in your company. Second reason is capacity planning, right? You just want to understand, how the capacity is divided and actually you being used up on a daily basis in your cluster. When are you really going to need to maybe expand it? Have you over-provisioned? Have you under-provisioned? And thirdly, really, it's just about getting visibility into things happening in your cluster. And the way we've delivered it is is that we're dog fooding our own technology here. So we've delivered Zeppelin reports along with SmartSense 130, pre-built Zeppelin reports that will tell you that, hey, these were the top 10 jobs, these were the top 10 tenants, right? And this is how they were using the cluster, this is how much CPU memory they consumed, right? And we're also opening up the option for you to build your own dashboards or your own reports with Zeppelin against the Embari metrics and application server timeline, AT application timeline server data, right? So this is really, really very, very cool feature that we've shipped. The third thing we're doing in the ops space is also very, very key and will make life very easy. So if you've ever operated a Hadoop cluster, you know that it is a distributed environment. You have 50, 100, however many nodes, 500 nodes, and the logs are spread all over, all over that cluster, right? HDFS logs, yarn logs, and what have you. Now we're giving you the capability to actually be able to search and view those logs from within Embari. We index all of them for you into a Solar instance, and we give you a UI in Embari to be able to search logs across your entire cluster. And there is a UI associated with that, which allows you to do some things like time range searches and searches by specific log levels and things like that, which is really, really very, very useful. Along with that, we give you all the bells and whistles, such as, hey, if you've ever looked at Embari, you can drill down into a specific node, a specific service now, and if you see you probably cannot see it in the back of the room, but all the way on the right, there's a link now saying that, hey, I want to open the log for this service on this node from Embari, right? And we go and fetch that log for you, and you can look at it from within Embari, right? Extremely, extremely useful service from an ops perspective. Let's touch a little bit on Hive now. In Hive, we have tech previewed a capability called LLAP. Now, if there are any Star Trek fans in the audience, then you probably know what this means, right? LLAP, long live and prosper. Our version of LLAP is long live and process, right? Long live and process data. And the idea behind LLAP is that it targets the use case of interactive queries. So if you've ever worked with Hive, you know that you can give Hive, right, hundreds of terabytes or petabytes of data, right, and do a very complex OLAP query, and it will actually go and crunch that query in an economic way, and deliver results to you, right, but on that extremely large kind of query that hits very, very large amounts of data, right, the expectation is that, hey, it's not going to come back in, right, 3 or 4 or 5 or even 10 seconds, right? That's an OLAP style workload. You're maybe finding a needle in the haystack on petabytes of data. That kind of query takes time. But what about use cases where, for example, you are like a Tableau user, right, or some BI tool, and you're not hitting petabytes of data or hundreds of terabytes of data. You may be hitting a 1 terabyte, 5 terabyte, 10 terabyte, 15, 20 terabyte data set, and you're dragging and dropping things on a Tableau dashboard, right, which is generating Hive queries underneath the covers. And that kind of person wants interactive response time, right? That he or she is not going to wait for 10, 15, 20 seconds. That's the use case that LLAP targets. And for those interactive queries, it's able to deliver very fast response time. It is a daemon that's always up and running, which means that it gets rid of the container lag that you may have seen for your techies out there, right? Yarn container lag. Sometimes there's lag in spinning up a Yarn container. With LLAP, because it's a daemon that's always up and running, we totally get rid of the container lag for this kind of use case. And it's also very smart about caching frequently used data. So typically, if you imagine how a Tableau dashboard is used, you're hitting the same data typically multiple times. You might be slicing and dicing the same dimensions and visualizing them in different ways, right? So LLAP is able to recognize that pattern on its end and say, it looks like this is frequently used data. I'm going to cache it in memory, and that's why it's able to serve that kind of interactive workload much, much quicker. Some of our initial tests on a 10 terabyte TP-CDS data set with LLAP yield, almost in all the queries greater than 50% performance gains. If you're not familiar with TP-CDS, I'm sorry I'm using that term, but TPCDS is a standard benchmark, a data warehouse benchmark, industry benchmark, built against a typical retail fact-to-dimension table type of schema. So it's used a lot in the industry, and that's the 10 terabyte TPCDS data set that we tested against. So interactive SQL LLAP is delivered as a tech preview. So let's switch gears a little bit and start talking about, our cloud strategy and how we're, thinking about the cloud. So I touched upon hybrid in the beginning as well. Let's talk a little bit about, what kind of things are we hearing from customers when it comes to the cloud? Why are they asking for cloud deployments? And some of you folks, I recognize you're already on the cloud, so you already know this stuff. Some of you might be thinking about going to the cloud or just wondering, well, what does Hadoop in the cloud really mean, right? The kinds of things we hear are like, look, agility is one of the top reasons to go to the cloud. If you're a line of business in a large company sometimes, maybe you don't want to wait for 6 months for hardware to be procured, right? For IT to procure hardware, rack and stack it, and things like that, right? Cloud is instant gratification. Virtual machines spun up within minutes, right? It allows you to bypass that sort of procurement process. No upfront costs. A lot of customers, not a lot, but some customers are moving from CapEx model to OpEx model, right? And they don't want to make huge upfront investments in hardware and infrastructure. So for those customers, cloud is very attractive too. The third one, which is really very important, is the kind of workload that you want to run. A lot of customers we talk to are just wanting to, use ephemeral clusters. For example, the most typical one that I hear of is, I've got a Spark job, a machine learning job that trains against the day's data that I've collected. It runs at night, updates my models, and then it goes away, right? And I don't need a cluster after that, right? For that particular use case. So that's a very good cloud use case because it takes advantage of the elasticity, right? In some cases, it's the other way around, where it's not a nighttime thing, but it's a daytime thing where people say, most of my data scientists are active on the cluster from 9 to 6 every day. After that, they go away. So I don't want resources up, at nighttime when there's not much activity. So that's kind of like the ephemeral elastic type of use case. But having said that, there are customers also who are doing long-running workloads on the cloud as well. So don't think that, hey, cloud is only just for elastic workloads. Yes, if you've got a cloud strategy, that's where you're going, and you want a long-running cluster on the cloud, that's entirely possible as well. There are price performance decisions that you have to make there. You have to find out if your cloud provider gives you sustained usage discounts, so with things like reserved instances or just sustained use discount, and that makes it cheaper to run long-running workloads as well on the cloud. So looking at the segment of customers, right, essentially the market is divided into two segments that we see, right, two kinds of use cases, if you want to call it that. The enterprise type of customers are asking for a hybrid strategy, and I touched upon some of this earlier as well. Key to the hybrid strategy is the notion of repeatable deployments, and one of the tools in our toolkit that allows you to do that is something called CloudBreak, right? CloudBreak allows you to take what's called an Ambari blueprint, right? If you've ever worked with Ambari, you're probably familiar with the notion of a blueprint. The blueprint over here is just how you think of a blueprint for a building. An Ambari blueprint is like a blueprint for a Hadoop cluster. So if you want a standardized way of deploying clusters on-prem and in the cloud, the blueprint is a key piece of technology that enables that, because it standardizes what your cluster is going to look like, right? So you can use CloudBreak to take blueprints that you've created on-prem and take that exact same blueprint and deploy it onto the cloud, right? And that's sort of a key part of the hybrid segment. And then those same customers, also want to, be able to consume other kinds of services on the cloud as well. If you're not wanting to use blueprints, of course you've got a platform as a service offerings as well on the cloud, such as Azure HD Insights, right, which also gives you some sort of peace of mind in terms of like, hey, I'm running Hadoop on the cloud, on-prem, and I want the same distribution, right, in the cloud, but I want to consume it in a platform as a service manner. manner, and you can also use that kind of strategy. But really, the key to hybrid is the notion of repeatable deployments, and Cloudbreak is one of the key pieces of technology that enables it. I'll touch a little bit. I'll show you some screenshots of Cloudbreak a little bit later as well. Then this sort of second segment that we see of customers are, that I just want a fast on-ramp onto the cloud, right? I don't really care about on-prem deployments. I want to be able to stand up a cluster as quickly as possible on the cloud within minutes. I want to pay for what I use, and I want it to be fully elastic. A lot of the times, these customers already have their data on the cloud on object storage, right? So it could be data on Azure Blob Storage or data on AWS S3 or Google Cloud Storage, right? And they want to be able to just spin up clusters, therefore, on the cloud, ephemeral clusters on the cloud in a very, very quick way. And we've got offerings, to meet that segment as well. Again, Azure HD Insight, which allows you to consume Hadoop as a platform as a service, right? Very, very quick stand-up of a cluster, and it decouples compute from storage. In the second segment, a lot of the times the requirement is that I want to decouple the storage from compute. The data lives on blob or object storage, and then the compute, which is the actual cluster, ephemeral cluster, comes and goes. So you may have a Spark cluster that comes, uses data on blob storage, outputs the actual analysis of the job back into blob storage, and then the cluster goes away, right? So that kind of use case also we can handle with things like Azure HD Insights. And now you've probably heard of an announcement that we've made at the summit called the Hortonworks Data Cloud on AWS. So we've got similar functionality on AWS as well now, which I'll start to cover a little bit later. So the key thing to remember is this: if you've got a cloud strategy, right, or you're thinking about one, we cover all of the three main cloud providers: AWS, Azure, and Google. If you want to consume Hadoop in a way where you're saying, you know what, I'm only going to take the storage, compute, and network from the cloud, which is the left box there, right? I'm only going to use the cloud as infrastructure as a service, and I'm going to run Hadoop the way that I always did, right? But on the cloud, right? We can make that happen for you, right? We've got the tooling to make that happen. But if you say, no, I don't really care about how this thing is deployed. I don't want to get into the business of deploying this thing. Just give me a very, very quick on-ramp. I want to consume it as a platform, as a service, right? Then we've got offerings to handle that use case as well. And talking a little bit more about HD Insights, I think I touched upon some of these topics already. Data in blob store, decoupled storage from compute. What kind of use cases is this good for? It's really good for things like, hey, I want to do an ETL process, right? I want to ETL a bunch of data certain times a day or certain maybe times a week, whatever the time period may be, right? Spin up HD Insights really quickly, with a click of a bunch of buttons, and do your ETL process, and then spin the cluster down. Spark, you can create Spark clusters with HD Insights as well. And Spark, as you know, can be, depending on what you're doing with Spark, it can be pretty memory intensive, right? It is a memory intensive workload. Once you bring the data into memory, then it actually becomes CPU bound, right? So if you've got Spark jobs that come and go, you can spin up ephemeral Spark clusters with HD Insights. Again, with just a click of a button, it's fully elastic, and it's an economic way of doing some data modeling as well. And really, HD Insights, if you look at it, is a top-rated solution. This is one of the Forrester reports. You can see that Microsoft HD Insights is all the way at the top. It beat all of the rest of the competition when it comes to consuming Hadoop on the cloud. And coming to some of our AWS announcements, if AWS is actually your cloud infrastructure provider, and you're looking for a very quick on-ramp from a Hadoop perspective on AWS, then we've got the Hortonworks Data Cloud, right? And there are a couple of things that we've done here. Number one, if some of you might have already be familiar with this, S3 is now finally a first-class citizen in Hadoop, right, in HDP. So if you've got data on S3, or if you want to utilize S3, right, as a data storage layer, HDC, when you spin up an HDC cluster on AWS, it's going to be using S3 underneath the covers, right, as the data layer, right? And it gives you all of the bells and whistles of the cloud, right? Decouple storage from compute, ephemeral clusters that come and go, utilize object storage, right? Pretty much single-click deploy of a cluster. This is one of the UIs behind HDC. You'll see, like, for example, that, hey, I've got 3 clusters that are already up and running, right? Easy to use UI. And one of the clusters is in progress. The other thing that we've done is we've also gotten prescriptive about what kind of cluster you want. So a lot of times for these quick cloud on-ramp use cases, customers come and tell us, what I just want to do, I want an ETL cluster. It just needs to have Hive on it, and maybe Spark on it, because I want to use one of those two things to actually just do some transformations, right? Give one of those to me, and I'll tell you how many nodes I want, right? So you go into the UI, you say, okay, I want an ETL cluster, 10 nodes, this kind of virtual machine, go. 15 minutes or 10 to 15 minutes, you have a fully functioning cluster, right? And then, so we've gotten very prescriptive about how we deploy the clusters. All of the sausage making is sort of hidden from you underneath the covers. You don't know how it's being deployed. We've automated all of it. You just say, I want an ETL cluster, or I want a data science cluster with Spark and Zeppelin on it because I have a data science use case, or I want an analytics cluster where I just want to do some reporting with LLAP, right? We take care of automating the provisioning of the entire cluster in line with best practices on your choice of virtual machines, right? And it's up and running in minutes and ready for use. So that was sort of the quick cloud on-ramp story, right? Now, coming back to some of the hybrid and enterprise stories, you're probably wondering, well, Newman, you've been talking about CloudBreak, right, and hybrid, then what is a deeper story there, right? And so if you've got an actual hybrid scenario, right, I'm going to recap a little bit more. The things that you want to strategize on. You want to standardize blueprints, right? Because if you have an on-prem cluster, there's some notion of what that cluster looks like, and there's some notion of what you want that cluster to look like on cloud. You probably want it to look exactly the same in the cloud, right? And I'll give you an example of that. So let's say you've coded a Spark application on HTTP 2.4, maintenance pack, I'll make it up 5, right? And you know that it works on those exact bits. And for some reason you want to now go on the cloud, you maybe want to burst on the cloud, right? And you want that application to just, guaranteed to work exactly the way that it's been coded up, but on the cloud now, right? How are you going to deploy HTTP on the cloud to make sure your application works as is? Blueprints are your friend, right? Because if you've got a blueprint for that cluster, you're going to take that exact same blueprint, you're going to input that blueprint into CloudBreak. If you've ever worked with CloudBreak, ever seen it, then this might be familiar with you. If not, then again, CloudBreak is a UI environment. It gives you a UI. You just upload your blueprint, which is essentially just a JSON document, into CloudBreak. You point to the cloud that you want, AWS, Google, or Azure, right? And you say, deploy this blueprint, please, on the cloud. Within 10 to 15 minutes, you have a fully functioning cluster that will very much resemble, or should technically exactly be the same bits as the bits you have on your on-prem cluster. So your application, your Spark application that I was telling you about, will pretty much work because it's the exact same bits, exact same configuration, exact same sort of environment, but running on the cloud. And this is key to hybrid, by the way, because repeatable, you don't want your clusters to be snowflakes, to be different on-prem or in the cloud. You want them to be consistent. Second is the notion of scaling up and bursting, right? Because one of the use cases for hybrid is that I've got some on-prem capacity, right? And maybe once in a while I need to burst out. You could be a retail customer, for example, where you're doing 50% of your business at the end of the year, in the holiday season, and that might be one of the reasons why you may want to burst out and use a hybrid strategy to burst out into the cloud, right? So again, this kind of tooling is sort of the starting point for being able to do those scenarios, because CloudBreak understands scaling as well. Auto-scaling, you can create time-based policies for when you want this cluster to scale up or scale down. So you can actually say that I want to add another 20 nodes in my cluster from 9 to 5 every day, if that's your bursting story. Or you can set policies like, hey, I'm running out of resources. Yarn is telling me, so CloudBreak is integrated with Yarn. and it has insight into the fact that maybe Yarn is running out of memory or CPU in your cluster. And you can set policies like, okay, it looks like I'm about to run out of memory in the cluster, and the culprit is probably maybe a data scientist came in and ran a Spark job. So I want to scale up a bunch of Spark nodes, right? Only the Spark tier in my blueprint. Cloudbreak is smart enough to be able to scale up only the Spark tier in your blueprint, right? And add maybe 10 virtual machines so that your job will complete on time. So that kind of bursting story, right, is also a common theme in hybrid scenarios. Number three, it's not on the slide deck, but I do want to touch upon it. Of course, is if you think about bursting or data movement, HDF also plays a key role, right? Because if you want to burst out your workload into the cloud, you got to make sure the data is on the cloud, right? Otherwise, what will your adding the CPU and memory do for you if the data is not there? So that's where HDF helps, where you can say that there's certain kinds of data that actually want to be synchronized between on-prem to cloud, or vice versa as well, right? And HDF can do that data movement for you, and it is really the glue that holds together a strategy where you've got multiple data centers involved, right, in your data platform. And HDF, and I'll expand a little bit on that a little bit. I don't want to steal Drew's thunder there, but even if you think about a non-hybrid data center strategy, where let's say you've got multiple data centers, you're a customer who just happens to have a global footprint, and you've got multiple data centers in your environment, how do you actually move data between those data centers, right? If you've got multiple data centers, and you may, in some cases, have multiple Hadoop clusters all around the world, and I see that from customers all the time, global customers who have analytics needs. Again, blueprints and HDF are kind of the two key pieces of technology that enable you to have consistency across multiple data centers from a Hadoop perspective. And HDF is the glue, the data movement glue that moves data between those data centers to deliver on that requirement, right? So whether you're looking at a hybrid private cloud to public cloud scenario, whether you're looking at a public cloud to public cloud scenario, the definition of hybrid has been evolving also to mean that, hey, I don't want to be tied into a particular infrastructure provider, right? What if I decide to change my cloud provider tomorrow? What can you do for me there? And again, HDP and Cloudbreak are key to preventing you from being locked into a particular infrastructure provider, because this tooling is cloud agnostic. You're just writing apps. You're going to write your data-driven apps. You're going to concentrate on your blueprints. The tooling deploys to whichever cloud you want to. So this prevents lock-in as well. So hopefully, I know that is a lot of information to take in. Hopefully it's given you a flavor for what our cloud strategy is, what kind of tooling we're developing, and how we're making your life easier from an ops perspective.
Awesome. Thank you, Newman.
Sure.